third use case, which is a fairly interesting use case and fairly prevalent use case as well, which is data privacy compliance. As we all know, any code that we write is always subjected to PCI, SOC, GDPR, etc. So when we deal with our consumer information, any information that carries critical consumer data is deemed as sensitive. So it is of our utmost responsibility to treat that data effectively. Treating effectively means we effectively got to encrypt that data, redact that data, or obfuscate that data if we are sending that data on an outbound channel, either to our syslog or a log file that gets carried to our Splunk dashboard, or perhaps gets passed over an HTTPS secure channel to another microservice. Because it's very hard to understand the lineage and provenance of sensitive data in a very complex microservice mesh. Especially when you're getting audited, a simple question is asked, how do you treat your customer data? It's very hard to have an effective answer to that. Even worse, if someone abuses your business logic flaw, they can touch these sensitive data elements. So it is important, first of all, to understand what is sensitive in the application. Thereafter, understand where is the sensitive data flowing through the lifetime or scope of your application. And then you further ask the question of whether this sensitive data is being redacted, obfuscated, or encrypted before it exits the crevice of your application. So let us switch back to the console and use Ocular to ask these questions. The first question that I'm going to ask is, give me all sensitive user-defined types in the application. Now, this is a very core value proposition of Ocular, which is unique, and no other solution can deliver this. Given that we have the code property graph, which is the graphical representation of your code at our dispense, we also have information flow at our dispense. We effectively built a natural language processing layer over these two subsystems that identifies how variables are named in your source code. Because often engineers define user-defined types. You know, if you're for sake of simplicity, if you're speaking Java, you define a user-defined type as class. You say class account, class consumer, class transaction. And then each of these user-defined types have attributes like first name, last name, address, routing number, account number. So Shift-left Ocular has the capability of identifying and looking at the entire type, and thereafter looking at how the type is named. Thereafter, that nomenclature is compared against various compliance bodies, and then that object is scored as sensitive. Note that the results returned here contain system-defined types, library-defined types, which are package-defined types, and even user-defined types. So in the code base, I have a particular model defined, which is called as class user, which I'll quickly illustrate to you in a moment. If I navigate to the code and shift to this particular directory called as model, note that we have a serializable user-defined type that contains various properties like first name, last name, passport number, etc. Ocular and Shift-left's code property graph has a capability of identifying this whole object and categorizing and classifying them as holding credentials, PII, and location data. This is really interesting because now you have a catalog at your dispense. But you want to go further and ask whether any of these types are being defined and used in your code, and if they happen to be leaking outside the edges of your application. So we'll use an example here where I'm picking this user model type as my source and a logger as a sink, because often as engineers, we want to identify and log everything either as info, trace, or debug so that we understand how our application is behaving from a tracing perspective. But often we commit the mistake of logging sensitive data like our user data or AWS secrets, etc. Now, if that happens, and if our data is not obfuscated, redacted, or encrypted, then we are in violation of compliance. So I'm asking a very simple question, and I get a simple flow in return. Now, this flow to me describes that I have my user-defined type with specific attributes being concatenated, prepared as a string, and then dispatched to a logger. And note that on carefully examining what is happening in the flow, it is clear that there is no encryption, redaction, or obfuscation function. Note that what we have done is batteries included provided to you as a customer effective encryption, redaction, and obfuscation functions that are available in the open source community perspective. But note that you might bring and build your own schemes for doing these functions. And if that's the case, all you have to do is augment the policies so that your packages are reined in and evaluated against to ensure that if it is violating that principle or not. Now, these findings are really interesting, but what you'd like to do is take these findings back to your engineers. And as we all know, engineers write code, commit the code in GitHub, and they often like for issues to be filed as GitHub issues. So let's take these findings, log them as a data flow. Thereafter, explode that flow as a JSON feed so that it's more conducive for an engineer to parse and make sense of. Now let's take that JSON feed and create a GitHub issue from our console. Because Ocular is essentially providing batteries included integration into various subsystems like I indicated in the past. So I just called a simple API, create issues in GitHub, and from your console, an issue was created into this project so that the associated engineer could effectively act on. Note that you can define your own description associated with the issue and add your necessary detail. All the necessary API function is provided to you to do this function. Now, some of the folks could, in interaction mode, create issues, but you could take this same function that I committed at the moment, encapsulate it into your CI/CD motion, so that every time you release a code, you have an autonomous system, run Ocular, conduct these degrees of evaluations, and then create issues in the appropriate project so that your engineers can track and resolve